Number 4, we have a parking structure that's going to be extended 40 feet on each side. And the picture's drawn here. Sorry, it looks a little messy, but I did the best I could. So x by x, the square here, is the original parking lot. And then we're extending it 40 feet on each side. And so the first part says, write an expression in terms of x in expanded form that can be used to represent the area of the new parking lot. So in order to represent the area, we have to find the formula for an area of, in this case it's a square because we're extending it the same amount, 40 on each side. And the area of a square or rectangle is length times width. So I'm going to use L for length, W for width. So first thing we have to do is actually represent the length and width. And if I look at the length and width, first of all, they're going to be the same because it's a square. And I'm just going to pick a side. So going down this side, I would have from here to here is x. And then since we're extending it 40 more, we need to add 40 to x. So x plus 40 would be the length. And then therefore the width would also be x plus 40. So if I have to find the area in expanded form, first thing I'm going to do is represent the length. Since it's a binomial, I'm going to use parentheses, x plus 40. And then I'm multiplying that by the width, x plus 40. So expanded form, right now it's in factored form. Remember, parentheses means factored form. So expanded form, you can either use the box method or you can distribute. I'm going to choose to distribute. So we distribute the x to both terms. So x times x is x squared. X times 40 is 40x. And then we distribute the 40 to both terms. So 40 times x is 40x. And then 40 times 40 is 1600. So from here, I look at the two middle terms here, and I notice that I can combine these. Since they're both positive, we're just adding 40 plus 40, which would be 80x. So my final polynomial is x squared plus 80x plus 1600. So that's the area written in expanded form. Alright, the second part then says explain how your expanded form is demonstrated in the area model. So looking back at the picture, we're going to look at what we got for the expanded form and find where x squared is, where 80x is, and where the 1600 is in our picture here. Well, if we're trying to figure out what x squared represents, looking at my picture, which piece has an area of x squared? Well, it would be the shaded square here, the original parking lot, because x times x is x squared. So it's the large square I would say the large square's area, or you could also say the original parking lot. And then where's 80x in our picture? Well, I don't see 80 anywhere, but I do see two rectangles. Each rectangle, if I shade this in, what would the area of this rectangle be? Well, from here to here is 40, and then from here to here is x. So that rectangle has an area of 40 times x, length times width, so 40x. And then this rectangle is the exact same thing. It's a 40 by x, so another 40x. So 80x is the combined area of the two rectangles. Alright, and then last but not least, where is the 1600? Although it's a big number, it's this little piece here. And how come that is the 1600? Well, from here to here is 40, and then from here to here is 40. And if I multiply 40 times 40, that's 1600, length times width. So lastly, the 1600 represents the area of the smaller square. And that's all.